the second lesson of week 3, guys, and we're pretty much going to be doing the same thing that you just got through doing. You're given some information, you need to write an equation. Okay, so these are sinusoidal regressions. They're scatter plots. You've done scatter plots since Algebra 1, but these are a little different. These are using the sine curve. If you'll look at these heights, they go up and they come back down. Well, when you're talking about a Ferris wheel, that height is just going to keep repeating itself. And so this is just going to keep going up and down and up and down. And so it's making that sine curve. All right, so it says the first Ferris wheel built was created by Gail Ferris in 1893. It had 36 carts on a wheel, with each cart able to hold 60 people. So it's a very large Ferris wheel. It says the chart shows a height of a cart at various points in time. Okay, so really all we need, we're not going to plot every one of these points. We need 2 points. We need a minimum and a maximum. And once we have those 2 points, we can find anything. And if you look, I have a minimum height of 8 meters here and a minimum height of 8 meters here. I'm going to use this one because it's 0, and so it's easier to deal with. So this is going to be our minimum. All right, our maximum is going to be at 84. Okay, so I'm going to come down here and I'm going to start graphing that. So 0, 8, let's put that right there. So there's a point, and I don't need a bunch of tick marks. Just do exactly how I have it. My maximum, I'm going to go back more to the middle of the graph, is going to happen at 4.5 minutes. And again, this is our max, so I'm going to put it up here. And this is going to happen at 84. So right there. Now, this is only half of a period. So that means I'm going to need another point right here, and I need to find this value. Well, here's how you do it. Okay? This distance from this minimum to maximum is 4.5. Well, that means this distance has to be the same. So it also needs to be 4.5. So if I add 4.5 and 4.5, I get 9, which that is the point that was given to us, but that's not always going to happen. Now, I also have to have the midpoints. So I know somewhere right in the middle, I'm going to have a midpoint, and I'm going to have a midpoint, but we need to find those values. So how do you find in between 2 numbers? Well, you add them up and you divide by 2. So if I were to add 84 and 8, I'm going to get 92, Divide that by 2, my middle is 46. So that's the middle of the graph. That will be your vertical shift. All right, now I also need this middle. Well, if I add up 0 and 4.5, divide that by 2, you get 2.25. And then add up 4.5 and 9, divide by 2, you get 6 and, let's fix that, 6 and 3/4. Okay, so there's one full period. All right, now part B, we've already answered. It says, what is the period of this graph? Well, we've graphed one full period from minimum to minimum, and it took us, it was 9 minutes. Now make sure you have your units here. 9 minutes. And it says, what does this represent? Well, this is the height changing. Well, why would it change? You get in a cart, that height increases, that height decreases. So 9 minutes is the time. Okay, it's time because we're looking at the x-axis. So it's the time it will take a cart to go around the wheel 1 time. Okay? And then C says, what is the amplitude and what does it mean? Well, remember, amplitude, we can find amplitude a couple of different ways. We know amplitude is half the distance from the top to the bottom. So I could find this distance here and divide it by 2, but I already have these numbers, so all I have to do is 84 minus 46, or 46 minus 8. So when I do that subtracting, I end up with 38 meters. Okay, 38 meters. And we're talking a height, so again, make sure you have your units. Well, what does this mean? Well, here's the middle of our graph. From the middle of our graph, the height it varies by 38 meters. And that word varies is important here. So basically, this is the variation in height a cart is from the average height. Okay, so the variation in height a cart is from the average height. So variation there, that's your key word. Part D, what is the vertical shift? What does that mean? So vertical shift, remember, is the middle of your graph. It's the new x-axis. So you're centered around 46 meters. So that's your vertical shift. Well, how did we get that vertical shift? How did we get that 46? We took an average. Okay, so that's exactly what it is. It is the average height. I just froze here. So it's the average height to the ground. Okay, the average height to the ground. I spelled average wrong, but whatever. Okay, so part E, write the regression equation, the sinusoidal regression equation. So we're just writing the sine equation, okay? Well, we've already talked about amplitude. We know that amplitude is 38. It might be plus 38. It might be positive 38 in the equation. We've talked about D. We know D is 46. We know the period is 9, and that's what's going to help us get the B. So I'm going to take 2 pi over B, set it equal to 9 over 1, and do my cross multiplying. That's a B. So B will be 2 pi over 9. All right, now we've got the A, we've got the B. We do not have C, and remember C is your phase shift. Well, remember the original sine curve starts at the origin, goes up and down. We're not looking for a minimum or maximum. We are looking for a middle point, a midpoint. Well, we have one right here. This is our closest. So that's what we're going to look at. We're shifting forward. So let me come down here. We're shifting forward, so minus 2 1/4, which is 9 over 4. So whatever that is, change that to a fraction. Hopefully we can change that to a fraction. And then I've got my 2 pi over 9 here, that's my B. And then when we write our equation, we're going to distribute that out. Okay, something else we've talked about. We're looking at this point and it is going up. So when I start writing this equation, that A is positive 38. Okay, so now we distribute and we get 2 pi over 9x minus, when I distribute to the second part, the 9's are going to go away, the 2 and the 4 will reduce, so pi over 2. And then all we have left is plus 46. Okay, so there's our equation. Now, before we go any farther, I'm going to check that in the calculator. So we had 38 sine 2 pi over 9, and then don't forget your x. A lot of people will do that, and then they end up with a straight line. Let's see, 2 pi over x minus pi over 2, and then I'm going to close parentheses, plus 46 was the middle. All right, so I'm going to go to window and let's set it up exactly how our graph looks. On the x-axis, we go from 0 to 9. And you could say we're counting by ones. You could say we're counting by 2.25s. It really doesn't matter. 99 probably would not be good. So let's fix that. Let's just go ones. Y minimum, we're starting at 0. we're maxing out at 84. And again, it doesn't matter. You can put ones or whatever. And then I'm just going to hit graph and make sure that we're correct. And what I would do, as soon as it's done graphing, let's check our points. And let's make sure our points are on here. So I'm going to hit trace. 4.5, 48, we have that point. 0, 8, 9, 8. Here's the big ones though. I would check 2.25, and there you go, you're at 46. And then our other point was at 6.75. And there's that point. So our graph looks good. Everything matched up. Now, part F. When will the rider be 15 meters from the ground for the first time? Well, this is a number that they're wanting you to plug in. So you need to determine, do I plug it in for X or for Y? Well, it says meters. So that's not a time. That's going to be a height. So this is going to be a Y. So you all know by now, if I want to plug something in for Y, the only place I can do that is right here. So I'm going to go down to Y2, press 15, hit graph. Now, you'll notice the question says, when will it be 15 meters from the ground for the first time? Because remember, this is just going to keep repeating. Well, the first time would be right here. So I need to find that intersection. So second trace, number 5. And you need to arrow down closer to the other one. That probably will work. And then enter, enter, enter. So here's where I'm 15 feet off the ground, and it would be 0.883. We'll stop there. And then remember, we were in minutes. So this would be where's my cursor? 0.8 through the 83 minutes. Okay? And kind of look at your graph. 15 is going to happen way down here close to 8. So almost about a second. I would say that looks pretty legit. Then it says how many minutes. So we want an answer for X. Is the cart higher than 15 meters? Is the cart higher than 15 meters? Well, guys, from here to here, anything above that's where it's higher than 15. So I want to figure out how long that takes. I want to know this distance right here. Well, I've already found the first time. All I need to do now is find the second time and then subtract the two. So we're going to do the same thing. We're going to find the intersection. But we already know this first one, so I now need to arrow all the way back over to the other side. And I think once I get over that hump, we should be okay. All right, so enter, enter, enter. All right, so there's our second time, 8.11. I'm going to go ahead and round and say 7. Okay, so to find how many minutes it passed by, I'm going to take the upper boundary, which was 8.117, minus the lower one, and you end up with 7.234, and again, those units are minutes. So that's how long, if you're riding one time around that Ferris wheel, you will be 15 feet over the ground, or above the ground, or more, for 7.234 minutes. Okay? Then it says, what is the diameter of the Ferris wheel? What is the diameter of the Ferris wheel? Well, guys, looking at this, the lowest you're going to get is 8. The highest you're going to get is 84. So the diameter is just going to be that difference between the two. So this is 8 feet off the ground, which makes sense. You would not want a Ferris wheel going all the way down to the and scraping the ground. But you need to find the difference between the two. So when you subtract them, you get 76 meters. Okay? Moving on. The data in the table represents the average monthly temperatures for Baltimore, Maryland. It was collected over many years, which tells us the data will not vary much from year to year. Essentially, the data will repeat each year, and so it is cycle or periodic. Periodic data can be modeled by a sine function or a sinusoidal Other examples of periodic data include tides, which we'll look at one of those in your assignment, hours of daylight, and so on. The goal of this problem is to come up with a good model for the data. So we're talking about temperature, and what they're saying is, and this is going to repeat every year. In January, it gets colder throughout the summer. Look, there's August, it's pretty hot, and then it starts falling back down. Well, then the next year, the same thing's going to happen. So that temperature goes up, comes down, goes up, comes down. So it's following that sine pattern. Okay, so it wants me to find a regression equation. Well, just like the last one, I need a minimum and a maximum. Okay, we need a minimum and a maximum. Well, I see a minimum temperature here. Okay, so we're going to use that point for the min. That would be 131.8. It looks like a maximum right here. So that would be 777, and that is our max. And that right there is all I need. Okay, so I'm going to start graphing this just over on the side. Let's get an idea of what it's going to look like. Remember, we have to label. So X is our month. Y would be our temperature, and it's in degrees Fahrenheit. We have a minimum at 131.8. We have a maximum at 777. Well, guys, then I have to have another minimum here at 31.8. Well, this distance right here from 1 to 7 is 6, and I know that just from subtracting. So 7 plus 6 is 13. So there's one full period from 1 to 13. Now I also need middle points. Okay, so remember, how do I find the middle? Well, I'm going to add up these numbers and divide by 2. So when I do that, I get 54.4. And guess what? That's the average. That's your average temperature for, where are we at? Baltimore, Maryland, throughout the year. That's your average temperature, and that might come up here in just a minute. All right, now I need this number. Well, what's 1 plus 7? 8. Divide that by 2, I get 4. Okay, I need to average these. When I add those up, I get 20. Divided by 2, I get 10. So there's my one period. Now we need an equation. Okay, so we know the amplitude. Okay, well, your amplitude is the distance from 77 to 54.4, or 54.4 to 31.8. So all you need to do is subtract those, and you get 22.6. Okay, now let's talk about that before we move on. The amplitude is how much it goes up and down from the average, from the middle of the graph. So what that means is your temperature, or the temperature in Baltimore, Maryland, varies 22.2 degrees Fahrenheit from the average temperature. Well, what was the average temperature? 54.4 degrees Fahrenheit was the average yearly temperature. Okay, because this is for the year. So these are little questions that could come up on an assignment. So now that tells me D, remember D is the middle, or the average, is 54.4. Now we need to know the period, and the period will help me get the B. Well, I know my period starts at 1, ends at 13. Well, what's that distance? It's 12. Okay? That should make sense. 12 months is one period. That makes perfect sense. So to find B, I'm going to take 2 pi over B divided by 12 over 1, do my cross multiplying, and so B will be pi over 6. All right, so now we've talked about our A, we've talked about our B, we need C, and we've got D right here. Remember, for sine, I want a midpoint. Well, there's my midpoint right here. We're going to go forward 4. So for my phase shift, we're going to go forward, so minus 4. And remember, I'm going to take that pi over 6, and I'm going to distribute that. So your equation would be 22.6, and it's positive because we're going up, sine of pi over 6x minus 2 pi over 3, because 4 over 6 will end up reducing. And then we have our vertical shift, which is 54.4. So there's your equation. And guys, I would again, make sure you're checking this stuff in the calculator, okay? Now, this is where it starts getting tricky. It says, use the regression equation to estimate the temperature on July the 4th. What will you plug in? All right, remember, X is in months. This is month 7, but it's into month 7. So this is going to be 7 and a fraction, or 7 point something, okay? I know that this is the 7th month of the year. This is the 4th day out of how many days are in July? That would be 31. So for plugging it into the calculator, you're going to have to make this improper. Okay, so remember, to make it improper, I'm going to multiply 31 times 7, and then I'm going to add 4, and you should end up with 221 over 3. And that will be plugged in for X because that is a day that was given. Okay, so I'm not going to go put in the calculator, but guys, make sure you know how. You will have to graph this in Y1, fix your window, make sure it looks like our graph. Once it graphs, I can hit trace, type in 221 divided by 3, and you should get 76.948 degrees Fahrenheit. So make sure you know how to do that. Hit trace again. Now we want to find the average temperature on Christmas. Okay, now we know December is the 12th month. Christmas is the 25th day out of, again, 31 days in December. All right, so when you make that improper, you get 397 over 31. So you will trace it for that value, okay? If your window goes all the way to 13, this should fall in that window, so you shouldn't get any errors at all. And then your answer that your calculator will give you is 31.916 degrees Fahrenheit. Okay? Any questions, make sure that you are emailing me. Our Google Meet will be on Wednesday at 12:30 like normal. Guys, it's a great time to take advantage because we work out problems together. And it's a lot of the same problems that people are missing when they're emailing me. So make sure you check that out. Guys, I hope you have a good week.